So we're going to take a look at how we calculate mass and balance for the P-Mentor using a manual method, using all the information from the AFM. So what I would say is for the P-Mentor, it's slightly more complex than other SEPs that you may come across. So it may take you a little bit more practice to get familiar with this and be able to do them slickly. But as with anything, practice makes perfect. So I'd encourage you to practice these as much as we can. We've got an Excel spreadsheet that will calculate them for you also. So what I would encourage you to do in the early days is to calculate these manually and then check them against that Excel spreadsheet to see if you've got them right. The other thing you can do is in the AFM, there's a worked out example. So again, spend a little bit of time having a look at the AFM and working your way through using that worked example. So everything we need for this calculation is in the AFM. So the first thing we need is the actual blank sheet, and you can see that this is here, and we're going to complete this as we work our way through the video. So to start off, we need two key pieces of information, and these come off of the aircraft's weight schedule. So you can see that this has all been completed for this particular aircraft, and each aircraft will have its own weight and balance schedule, and these are modified periodically, and if there's any modifications to the airplane, so make sure that we've got the latest version of that, which is in the AFM. And the two key pieces of information we need to start off with is the basic empty weight, which you can see is 469 kilograms, and the empty weight moment, which is 802.93 for V&EA. So one thing to note with the calculation sheet is you can probably see at the top we've got a choice of either putting weight in kilograms or pounds, and we can calculate the moment arm in either kilograms per meter or pounds per feet. In all honesty, it makes no difference which way you do it, but if you do it using pounds per feet, just make sure you keep that unit constant throughout, and equally the same for kilograms per meter. So keep the same unit throughout. So I'm going to stick to SI units, and we're going to use kilograms per meter. So you can see I've entered the basic empty weight. So we've got 469 kilograms, and we've got the moment as 802.93. So to that basic empty weight, we're going to add weight. So in this context, we're going to add a pilot weight of 85 kilos, a co-pilot of 80, and some baggage of 5 kilos. So we've entered those into that box. And then the column to the right is our arm. So to calculate the moment, which is what we're going to do next, we need to multiply the weight by the arm. So I've gone through and done those for each of those. So you can see 85 times 1.94 gives us 164.9. And I've worked my way through each of those, allowing us to complete that third column. And the next thing we're going to add is our usable fuel, the fuel that we've added to the aircraft. And you can see that the calculator uses specific gravity of 0.72. So we need to calculate the weight of the fuel using that figure. So we're going to use 70 litres of fuel. That's going to be our starting fuel. So we're going to times 70 by 0.72, which gives us 50 kilograms of fuel. So let's add that in. And then once again, exactly the same. We're going to times it by the arm, 2.139, which gives us a moment of 1.07. Those of you with the keen eye may have noticed the number of decimal places. So you can see the arms are to 3 decimal places. But actually in the example, it only gives that third arm to 1 decimal place. So I'm going to keep it exactly the same as they've done in the example in the AFM. We then need to calculate our takeoff condition in kilograms, our weight essentially. And so we do that by adding all of the figures that we've got in that column above, which gives us 689. Do exactly the same for the moment. We're going to add all of those up in that column, and that gives us a moment of 1241.3. So then to calculate the takeoff C of G, we need to divide that number by the weight. And that gives us a figure of 1.82. And then the next bit is the slightly more complex bit that you don't often see in SEP aircraft. So the sheet asks you to calculate the percentage Mach, which is often something you see in bigger aeroplanes with much more swept wings. But this is the way that Tecnam have chosen to do this, so that's the way we're going to do it. So what we need to do is enter the weight into this formula. So we can see that we've got 1.82, and then we're going to minus 1.441. We're going to then divide that by 1.357 times by 100. So I would encourage you to use a scientific calculator to do that and put brackets in where they've put brackets in the calculation. And you'll see that that gives us a percentage Mach for the takeoff of 28%. Down to the next box. So the green one again, are fuel required, or you might often see this referred to as trip fuel. So the amount of fuel that we're actually going to burn while we're flying. So once again, it's in same specific gravity. So we're going to use 20 litres of fuel. So we're going to do 20 times by 0.72. So we're going to use 14 kilograms of fuel. We then need to calculate the moment of that. And again, they've not made it very easy if you're not familiar with doing this. So we need the arm, which isn't actually displayed in the box. But if we think about it, the fuel is in the same place as it was when we started. So it's going to have the same arm, which is that number there, that 2.139. So we're going to bob that in there, 2.139. Again, multiply the weight by the arm, and that's going to give us that moment of 29.9. We then need to calculate our weight on landing. So we took off with 689 and we used 14 kilograms of fuel. That's the only thing that's disappeared since we've been flying, unless we've lost a passenger on the way, which is pretty unlikely. So we minus that number by that number, gives us 675 kilos. So that's our landing weight. We then need to calculate the moment of that. And so we've got two numbers that we can use to calculate that. We've got our starting moment and we've got our landing moment. So we minus the landing moment from the takeoff moment, which gives us a figure of 211.4. We then need to calculate our landing CFG in meters. So same as we did before, we're going to divide the moment by the weight, and that gives us a figure of 1.81. And then the last thing we need to calculate is that landing CFG in percentage Mach again. So we're going to put that 1.81 in there. We're going to carry out that calculation as it is in the box, and that gives us a landing Mach of 27%. So that's all the information that we need to then put that into the envelope, and we'll find out whether we're in the envelope for the aircraft. So hopefully this is the bit more straightforward bit. So we've got a percentage Mach of 28. So we've put that on the x-axis, and then we've got a takeoff weight of 689, which we've popped in the y-axis. So I've just got arrows to that, and that gives us that red dot there. Exactly the same for the landing. We can see the CFG has moved forward a little bit. So we've got 27, and we've got a new weight of 675. And again, we can plot those on there. So if we get rid of the arrows, we can see red is our takeoff and green is our landing. So as we burn fuel, the center of gravity, or the percentage Mach, is going to move forwards, or the number is going to reduce as we go. So when you calculate this, if it's the other way around, we've probably done something wrong. So a little bit of a gotcha there. So that's why it's worth kind of considering what sort of answer am I expecting. So I'm expecting on landing to weigh less, and I'm expecting my percentage Mach to be less. If you don't get that, then it's likely that something's gone wrong. What I would do, as you can see, it's a pretty, as I say, quite a complex process the first time you do it. But I promise you, once you've done it a few times, it will get easier and easier. But definitely double check your numbers when you do these. You can see that it's really easy to get one number wrong, and getting one number wrong will then obviously impact on every other calculation that follows in that section. So take your time and spend some time going through them. And again, if you're unsure, there's always an instructor around, so grab one of us and ask us to give you a bit of a hand. And as I say, just keep practice, and it'll become much more straightforward.